Yeah, hi friends, welcome back to this session. In this session, we'll discuss about a delta star connection, because in the last session we explained delta. Before that we explained star star also. Generally in three-phase transformer we are having star star connection, delta connection, third one delta star, and the fourth one star delta. We completed star star and delta. Here we got YY12, or I can say YY0 clock. Here we got DD12, or I can say DD0 clock we got here. Now let me go for delta star connection. Delta star connection. Delta star connection. Here we are having two, they are having one chance. One first case is there. Similarly, second case here I'll write. Okay. So let me take primary is in delta connection, secondary is in star. So we'll take primary 3 windings. I'll take secondary also 3 windings. Similarly, in case 2 also we'll take primary. I'll take 3 windings here. Secondary will take 3 windings. Secondary we will take 3 windings here. Okay. And primary represents, I told you already, primary vector represented with the capital letters. So I can write here A1, A2, B1, B2, C1, C2. This is small a2, small a1, B2, B1, C2, C1. And here also similarly A1, A2, B1, B2, C1, C2, A2, A1, B2, B1, C2, C1. And A1, A2 vector represents capital A, here B, capital C, small a, small b, small c. Here also A, B, C, small a, small b, small c. I told you suffix 2 terminals marked with dots here, dots, dot, dot, dot. Here I can show dot, 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 dot. Right? Now, see in case 1, it is a delta winding. I'll give input to A2, B2, C2, and connections will be like this: non-dotted to dotted, or I can say undotted to dotted, undotted to dotted, undotted to dotted. In star, I'll take output from A2, B2, C2 by providing neutral to A1, B1, C1. Okay. In case 2, primary I'll take same as that of your case 1. So like non-dotted to dotted, non-dotted to dotted, non-dotted to dotted. Here instead of taking output from A2, B2, C2, I'll take output from A1, B1, C1 by providing neutral to A2, B2, C2 with These are the 2 cases, and after this I'm just going to explain 2 more cases, because in delta star we'll be getting 4 cases here. Okay. So first delta connection. So first of all, by default try to draw A2, and this is what B2 vector, and this is what I can say C2 vector. Okay. You observe clearly in that diagram, A2 means indirectly which vector? A2 means indirectly which vector? C1. C1. B2 means indirectly which vector? A1. C2 means indirectly which vector? B1. Now if it is A1, if it is A2, A1, A2 means what? It happens, A1, A2 nothing but capital A is the vector having here. B1, B2 here having capital B. C1, C2 here having capital C. Now you have to draw secondary vector parallel to primary. Yes, it is A1, it is A2. So we should draw A1, A2 Without seeing secondary, I'll simply draw. After that, we'll decide whether this one is wrong or right. A1, A2, B1, B2. So I can draw here B1, B2, B vector. C1, C2, C1, C2, C vector, this small a vector. But this is not correct. Why? Because your secondary is a star, but what we drawn here delta, which is wrong. From this wrong, you have to write the correct one. How? You just take any one reference. Okay, let me take A1, A2 vector. I will take here A1, A2. I will take A1, A2. Nothing but small a vector. So here A1 is short with B1. That means here wherever B1, B2 vector is there, this orientation should not change. It should be like this only. B1 should be here, B2 should be here. Okay, it should be left side, it should be right side. So B1 should be like this only. At the same time, B1 should be short with A1. Yes. Therefore, ultimately B1, B2 I have to draw here. So now tell me, this is what I can say B1 and this is what I can say B2 vector. This is what B vector. And C1, C2 I have to draw such that your C2 should be short with B1, A1. So C1, C2 should please take here and just draw like this, such that C1 should be short with A1, B1. So then your C1 is here, C2 is here. This represents a C vector. So A1, B1, C1 short with neutral N. This is correct because your connection terminals are A2, B2, C2. Yes, A2, B2, C2. And A1, B1, C1 are short with neutral. This is correct completely. And what is the phase sequence here? A, B, C is the phase sequence here. A, B, C is the phase sequence here. And before comparing line voltage of secondary with the line voltage of primary, what you have to do? Simply, please try to draw star equivalent for this delta. I told you, if it is in delta, I cannot compare line voltages. It should be in star. Therefore, A2, B2, C2 has are nothing but connection terminals. That means A2 should be there, B2 should be there, C2 should be there. But whereas A1, B1, C1 are non-connection terminals, which should be striked off. So A1 should be strike off, B1 should strike off, C1 should strike off. Now it is the vector it is the vector connected to A2. So this is what I can say A vector. This is connected to B2, B vector, connected to C2, C vector. What is the phase sequence here? AB is the phase sequence. Now compare this, okay, star and this star. So if you want, you can see once again, A2, B2 nothing but primary, primary line voltage. A2, B2 means primary line voltage. In secondary, line voltage means what? A2, B2. This is what A2 and this is what B2. So if you compare this A2, B2 with this A2, B2, you'll get like this. This is what A2, B2, capital A, capital B. And if I draw this A2, B2, it is somewhere here. So what I can say small a2, small a, and this is what I can say b2, you can say b. See, you can take any one, you can take any vector, you will get angle correct only. If you take a2 as reference, with respect to a2 is the leading by angle of 30 degrees. With respect to b2, small b2, I mean with respect to primary side b2, second side line voltage is leading by 30 degrees. That means I can write simply here, secondary line voltage leads primary line voltage by an angle 30 degrees. That is, answer you can say 30 degrees lead, you can say, or plus 30 degrees you can say. And for telling the time, I told you already, since in a clock tool is reference, we had seen A2 should come at this position. So you have to compare small a with a capital A, not a small b with a capital B. So for making understand only, I just drawn this one. Otherwise not necessary. Simply can just draw like this. This is 12 o'clock. You please compare small a with the capital, that's it. This is capital A, which represents minute needle. Small a, which represents hour needle. It is at 11 o'clock. So answer delta star, capital D. Second is star, small y, dy, okay, dy 11, dy 11 is the angle here. That means with 12 is reference for us, capital A is reference for us, primary line voltage is reference for us. When compared to primary line voltage, secondary line voltage is leading by an angle of how much? 30 degrees. What is the angle between 12 and 11? 30 degrees. That's why I said dy 11 or second line voltage leads primary line voltage by an angle 30 degrees, or plus 30 degrees lead is the answer, or plus 30 degrees is the answer. Now similarly tell me what about in this case? There is, see, case 2 primary, case 1 primary same. So please try to, if you understand this one, I think you can tell answer this one very somewhat fast. This is what I can say A2, this is what I can say B2, and this is what I can say C2, and A2 nothing but C1, B2 nothing but A1, C2 nothing but B1. A1, A2 capital A, B1, B2 capital B, C1, C2 capital C. Is it clear? Right. Now, without seeing this secondary connection, you please try to draw without seeing this. After that, we will decide whether this is correct or not. Okay. Secondary vector A1, A2 should be drawn parallel to capital A1, A2 like this. Small a1, small a2 should be drawn parallel to capital A1, capital A2. Small b1, small b2 should be drawn parallel to capital B1, capital B2. Small c1, small c should be drawn parallel to capital C1, capital C2. You see, this one is wrong. Why? Your secondary is star, but you just drawn delta. So you just take any one reference. I taken A1, A2 is what small a. Your terminals are, I can say, observe clearly, A1, B1, C1 are connection terminals. There I am just taking output. Therefore, this is what I can say A1 and A2, and tell me, your B2 should start with A2. Here B2, here B1. This is what I can say B vector, right? B2, B1. Okay, this should be like this only, but at the same time B2 should be started with A2. Because B2 should start with A2, no? Like this. Therefore, this vector B2 is here, B1 is here, this becomes B. Is it clear? Now what we have to do? Once again. Yeah. C2 should be started with B2, comma A2. So C2 is here, C1 is here. Please draw like this. C2 should be here. Orientation should not change. This is small c. This A2, B2, C2 start with neutral N. ABC is the phase sequence here. Now please try to draw star equivalent in primary delta side. Star equivalent. Before that, what I said, you should strike off non-connection terminals A1, B1, C1 should strike off. A1 should strike off, B1 should strike off, C1 should strike off. A2, B2, C2 should be there. A2 should be there, B2 should be there, and C2 should be there. So, okay, now this becomes A, this becomes a B, this becomes a C. What is the phase sequence here? ABC is the phase sequence, ABC is the phase sequence here. Now what I told, you have to compare always small a with a capital A. In a clock, this is what capital A. If you compare small a, it will be somewhere at no. This is small a at 5 o'clock. So this is 12, 6, 5 o'clock. Now answer please. Delta capital D, star small y. What's the time here? dy5 is the answer. Or secondary line voltage lags primary by angle how much? This total how much? 180. What about this angle from here to here? 150 degrees. So I can say secondary line voltage, secondary line voltage, secondary line voltage lags primary line voltage, by an angle, by an angle 150 degrees, okay. So ultimately you are getting deltas of two connections. Number one, d by 11, next d by 5 plus 30 or 30 degrees lead. Here I can say that secondary line voltage lags primary line voltage by angle of 150 degrees. Okay, please note down. So in delta star, let me take a case 3, and here also, I mean case 4 I'll take. So let me take once again, primary winding will be having primary side will be having 3 windings because it is delta. Secondary 3 windings because it is star. Once again here, primary will be having 3 windings. Secondary winding will be having secondary side will be having 3 windings. This is A1, A2, B1, B2, C1, C2, A2, A1, B2, B1, C2, C1, and this represents A1, A2 represents which vector? Capital A, capital B, capital C, small a, small b, small c. I just showed suffix 2 terminals should be marked with the dots, okay. And similarly here also, A1, A2, B1, B2, C1, C2, A2, A1, B2, B1, C2, C1, capital A, B, C, small a, small b, small c. So here let me show dots with the A2, B2, C2, small a2, small b2, small c2. Next guys, observe. In case 3, just like case 1 and case 2, I'll give input to A2, B2, C2 only. But some difference is there. You observe clearly case 1, case 2 diagrams in primary. There I went from undotted to dotted. Just if you want, you can check there. Now I'll go from a dotted to undotted, dotted to undotted, dotted to undotted. But I'll give input to A2, B2, C2 only. Though you are giving input to A2, B2, C2, there is difference between this connection and case 1, case 2 primary connection. Yes, there between A1 and A, I just connected from my A1 to B2. Now I just connect from A2 to B1. Difference is there. And here I'll take output from A1, B1, C1. This is one chance, okay. This one, fourth connection, I'll write this primary connection as it is. And instead of taking output from A1, B1, C1, I'll take output from A2, B2, C2, just like case 1 secondary. Case 1 secondary, whatever I just done, this one is same. Okay. Now, please let me continue. This is what I can say A2 vector. This is what I can say B2 vector. and this is what I can say C2 vector. A2 nothing but what? B1. B2 nothing but what? C1. C2 nothing but what? A1. Now here A1 is here, A2 is here. This is what A vector. B1 is here, B2 is here. This is what B vector. C1 is here, C2 is here. This is what C vector. Okay. Now you have to draw secondary A1, A2 parallel to A1, A2. This is what A1. This is what A2. So you can draw like this. This is what small a1, small a2 parallel to capital A1, capital A2. Small a. And B1, B2 will draw parallel to B1, B2 like this. B1, B2, B. C1, C2 I will draw parallel to C1, C2 like this. C1, C2, C. Is it clear? But this is wrong. Why? Your secondary is star, but you just drawn delta. You just write correct one from this. You just try to draw correct one. How? Take anyone. A1, A2. Please take anyone. Let me take A1, A2 here. Okay, A1, A2. A1, A2. I'll take like this. A1, A2. And this A2 should be started with B2. So this is what your B2 vector. See, this is what your B2, and this is what your B1. So B2 has to come and connect with the A2. So this B2 will come and connect with the A2 like this. So this is the vector we have to draw now. B2, B1. Orientation should not change. Similarly, C2 has to come and connect with the A2, B2. So C is here, C1 is here. So I can draw like this. This is what C2, C1, small c. A2, B2 short, A2, B2, C2 short with neutralian. Now what is the phase sequence here? ABC is the phase sequence here. And please convert this delta into star equivalent. Before that I told you one thing you have to do. A2, B2, C2 are connection terminals. You should keep like this only. A2, B2, C2. And A1, B1, C1 should be strike off. A1 should strike off. B1 should strike off. C1 should strike off. So since it is connected to A2, it becomes capital. It is connected to B2, it becomes B. Connected to C2, it becomes C. Okay. And what you have to do? What is the phase sequence here? ABC is the phase sequence here. Whenever phase sequence is same, then only you can start comparing. Okay. Now since I taken A2 is reference, just compare small a with the capital. That's it. In a clock, this is Stolo clock. Nothing but your small a is the keeping, and I'm just this star is just taken and just kept on this star. This capital A represents minute needle, long needle. Small a, this one, small a represents hour needle. It is at 7 o'clock. So what's the time here? Delta, capital D, secondary star, dy by 7. What is the angle from here to here? No, how much? 210 degrees. 180 plus 30 degrees. So I can say here secondary line voltage. Therefore, secondary line voltage lags primary line voltage by an angle 210 degrees. Okay. This is what case 3. Now let me go for case 4, please. Okay. So case 3 primary, case 4 primary same. So simply I can draw like this. A2 is what B2 is what C2. A2 nothing but B1. B2 nothing but C1. C2 nothing but A1. A1 is here, A2 is here. So it represents a capital A. B1 is here, B2 here, B. C1 is here, C2 here, C. Okay. Now, see, don't see this, secondary. Just draw. Generally, what I said, the secondary vector should be drawn parallel to primary vector. That please draw. Here, A1 is here. A1 is here. A2 is here. So please simply draw like this. A1, small a1, small a2 is small a, and small b1, small b2 should be drawn parallel to capital B1, capital B2, like this. B1, B2. Small c1, small c2 should be drawn parallel to capital C1, capital C2, like this. C1, C2. Okay, this is wrong. Why? It is in star. So this is wrong. Now please try to draw correct one from this. I'll take once again reference as which one? I'll take A1, A2. A1, A2 is what small a. Okay. Now what you have to do? Observe clearly. Your okay. Observe clearly. Your A1 should start with the B1. So your B1 is here, B2 is here. So you should draw like this. Then only B1 will come and in contact with your A1. B1, B2 is small b. And C1 should start with the B1, A1. So C1 is here, C2 is here. So C1 should start with A1, B1. I should draw like this. Therefore, this is what C1, this is what C2, C vector. So A1, B1, C1 should start with the neutral N. Now what is the phase sequence here? ABC is the phase sequence. And what you have to do before comparing? Just try to draw star equivalent for this delta. So before that you have to strike off non-connected terminals. A1, B1, C1 should strike off. That means A1 should strike off, B1 should be strike off, C1 should be strike off. A2 should be there, B2 should be there, and C2 should be there. This becomes capital A, this becomes capital B, this becomes capital C. Now in a clock, compare, just try to take the star and just keep on this star. Okay. So superimpose this star on this star. This is capital A at 12 o'clock, and small a is at what time? Small a is at this is what I can say capital A. Small a is at 1 o'clock. So what is the angle between 12 and 1 here? 30 degrees. So I can say first of all tell me a time. Prime is a delta capital D. Second is star small y. dy 1 is the connection, and obviously when compared with your primary, secondary is lagging or leading? Lagging by how much angle? 30 degrees. So I can say simply here secondary line voltage lags primary line voltage by how much? 30 degrees. That is, I can say, we can write like this. 30 degrees lag, simply I can draw like this, or it is indicating a lagging, no, so I can write simply minus 30 degrees I can indicate. Okay, this connection is wrong for this secondary, whereas this one is correct. Okay, so we got d by 7 here, d by 1 here. I can say secondary line voltage lags primary line voltage by angle of 210 degrees. Here secondary line voltage lags primary line voltage by angle of 30 degrees. Okay, so these are the 4 connections we are using in our country, delta star connections. Okay, first note down this. Right. Yeah. Okay, guys. Now, can you please conclude here? I told you in delta delta we got DD12, DD0, DD0. In star star Y by 12, Y by 0 are the connections. In a delta star, dy11, dy 5, dy7 and dy1 are the possible connections. Similarly, star delta also, if you try in the similar way what we tried in a delta star, in the similar way if you try, you'll get here yd11, yd5, yd7 and yd1 are the possible connections you are going to have. Please write as a note here. Okay. Similarly, the possible connections in star delta are yd11, yd5, yd7, yd1. Okay, please note on this. Okay. Now, see guys, here one thing you have to understand here. I'll divide total connections into two groups: phase group 1, phase group 2. Under phase group 1, you'll be having these connections: Y connection, Y connection, delta delta, Y delta delta, and one more connection is a delta zigzag star, where angles are, here I said it's star star comma delta delta. What are the possible angles you are getting between the second line voltage and the primary line voltage? 0 degrees comma 180 degrees. So phase group 1 means 0 degrees comma 180 degrees. Phase group 2 means plus 30, minus 30, okay, minus 210 degrees, minus 150 degrees. Okay, nothing but in this you are having connections. Okay. Delta star is the one connection. Star delta is one more connection. Next star zigzag star, zigzag star. So I can say this is what I can say phase group 1 and this is what phase group 2. This tabular card is very important. Under phase group 1 you are having star star, delta zigzag star. Under phase group 2 you are having delta star zigzag star. Here one important note you have to remember guys, very important. Star star can be operated in parallel with delta. So that there is no resultant phase displacement angle. So obviously circular currents will be less. If you start operating the star star in parallel with the star delta or delta star or star zigzag star, because of resultant phase displacement angle, circular currents will come into picture, which is not desirable. So that's what I want to see. Always transformers belongs to same phase group should be operated in parallel. That means the star star can be operated in parallel with the delta or star star can be operated in parallel with the delta zigzag star. Delta star can be operated in parallel with the star delta, but delta star cannot be operated in parallel with the delta or star star or something which belongs to phase group 1. Okay, so that I want to focus here. Transformers belongs to same phase group should be operated in should be operated in parallel to avoid circulating currents, okay, to avoid circulating currents, okay, just remember, please note down. Now see your classroom workbook, please. A three-phase transfer connections. Let me take here only classroom workbook. Two questions. So question number 28 in your classroom workbook is a theory question. Keeping it was asked in actually, so question number I am saying 28, GATE 1996. Keeping in view the requirement of parallel operation, which of the three-phase connections given below are possible? So he said that he has given options A, B, C, D. So which transformers connections can be operated in parallel? Option A he has given what here? Option A, option B, option C, option D. He has given here delta to delta star. Option B has given delta to star delta. Star to delta star. Option D, delta star to star delta. So which one is correct? If you see option A, delta belongs to phase group 1, but delta star belongs to phase group 2. They belongs to different phase groups, so should not be operated in parallel. Delta belongs to phase group 1, option B. Star delta also belongs to phase group 2, you should not operate. Star star belongs to phase group 1 and delta star belongs to phase group 2, you should not operate in parallel. Delta star belongs to phase group 2, star delta also belongs to phase group 2, I can operate in parallel. So option D is the answer. Please note down. Now please see question number 29 in our classroom workbook. Question number 29 in your classroom workbook. 29 I said 29. So he has given three single phase transformers are connected to form a three phase transformer bank. The transformers are connected in the following manner. So he has given like this. A1, A2, B1, B2, C1, C2. And he has given three connections here. A2, A1, B2, B1, C2, C1. Okay. He has given connection like this. A1 to B2, B1 to C2, C1 to A2. He has given like this. And he is asking the transformer connections will be represented by options he has given YD0, option B, YD1, option C, YD6, option D, YD11. These are the options he has given. So please, if you understand the previous our discussion, you can easily answer this question. So observe clearly where he has given input in the primary side, he has given input to A2, B2, C2, he provided a short to this A1, B1, C1. We'll do one thing, though he has not given these dots, is not without dots also we can solve, but let us keep dots also because we follow like that. This question number 29 asked in GATE 2008 now. GATE 2008. Okay. Now let me keep dots here, A2, B2, C2, small a2, small b2, small c2, A1, A2, let me show capital A, B1, B2, let me show capital B, C1, C2, let me show capital C, A1, A2, small a, B1, B2, small b, C1, C2, small c. Next, it's a star delta connection, star delta. So simply please write the star delta. So I'll do one thing, star delta, primary is nothing but star connection. So simply A2, B2, C2. If it is A2, what is the other terminal? A1. A1, A2 means which vector? Capital A. So if it is B2 means what is the other terminal? B1. B1, B2 means capital B vector. C2 means what is this terminal? C1. C1, C2 means this vector, what is C vector. Okay, right. Without saying this delta, I mean secondary, you just simply draw secondary vectors parallel to primary, as I told you. Okay, so A1, A2 should be drawn parallel to capital A1, A2, small a1, small a2. B1, B2 should be drawn parallel to capital B1, capital B2. C1, C2 should be drawn parallel to C1, C2 should be drawn parallel to capital C1, C2. But this is wrong connection. Why? Your secondary is delta, but you just drawn star, which is wrong. From this wrong, you have to draw correct one. Please try to draw A1 and A2 is what? Small a. And you just see, observe clearly, this A2 is nothing but which terminal? C1. B2 nothing but which terminal? A1. C2 nothing but which terminal? B1. So A2 is here. So please, that C1 should come and short with your A2. So C1 is here, C2 is here. This orientation should not change. This means it should be like this only and short with what I can say? A2. That means this is what your C1 and C2, correct, because A2 and C1 should short with each other. Next, C2 should be short with B1. This is what B1, this is what B2. You can draw like this. This is what B1 and this is what I can say B2. This is B vector. So A1, A2, A, C1, C2, C, B1, B2, B. Okay. Now please, what you have to do? Before comparing what I said, if your windings are in star delta, please convert them into star equivalent. So star equivalent. This is star equivalent, right? Star equivalent. Now what are the connection terminals here? A2, B2, C2 are connection terminals. So A2 should be there and B2 should be there. C2 should be there. A1, B1, C1 are non-connection terminals. So A1 should strike off, B1 should strike off, C1 should strike off. So now tell me, what is this vector? It is connected to A. So A. It is connected to, I can say that B2, B. It is connected to C2, small c. That's it. What is the phase sequence here? ABC is the phase sequence. ABC is the phase sequence. And here what is the phase sequence? ABC is the phase sequence. Now this one is correct. Now compare this star with this star. In a clock, you have to compare small a with capital A, not small b with capital B, I told, because I just made A2 at 12 o'clock. That means you have to compare small a and capital A. Okay. So this is what capital A, which represents a minute needle. Small a is here. Small a is here at 1 o'clock. So what is the connection? Primary star Y, secondary delta small d, YD 1 o'clock is the answer. YD1 is the answer. Okay. Option B is the answer. Okay. Please note down that.